I'm Anil Kumar, and in this video we'll go in details about curve sketching. So this video may be 10 minutes long. We have a function here which is x squared minus 3x plus 2 divided by x minus 3, and we will see how to sketch this particular function. Let's begin by finding x and y intercepts. Now y-intercept is always very simple to find. To find y-intercept, you need to substitute x equals to 0. So first step we will do is find y-intercept. That means x equals to 0 or value the function at 0. So f of 0 equals to what? So if I substitute 0 here, I get 2 over minus 3. 2 over minus 3. So that becomes the y-intercept. Right. Now let us find the x-intercept. To find x-intercept, let us factor the numerator, right? It's kind of simpler to factor, so we'll factor the numerator. So we can write this function as f of x equals to product of 2, sum of minus 3. So we could write this as x minus 2 times x minus 1 over x minus 3, right? So from here we get the x-intercepts, and we can say x-intercept is when f of x is 0, right? When f of x is 0, that means when numerator is 0. That is to say that x minus 2 times x minus 1 equals to 0, and that gives you two values. So the values are x equals to 2 and 1, correct? So what we have found here is one y-intercept and the other one x-intercept. So these are the x-intercepts and that is the y-intercept. So let's highlight these. Now let's continue and find other parameters. Easy is to find vertical asymptote and also the other asymptote, which could be horizontal or oblique. What do you think it is? We'll get back to that. Let's read vertical asymptote. Vertical asymptote is when denominator is 0, right? So x, we see we do not have a common factor here, so the vertical asymptote should be at x equals to 3. So x equals to 3 is the vertical asymptote. Now whenever you find vertical asymptote, it is a good practice to also see its behavior as the value of x approaches 3 from both left and right sides. When we say left side and right side, we basically mean that if I substitute a value for x which is less than 3, a bit less, which is, let us say, 2.9, and a bit more, which is 3.1. So if I write 2.9, we are approaching from left side. So we can also say, we can say limit as x approaches 3 from left side, and this is limit when x approaches 3 from the right side. So we take a value which is slightly more. When you substitute this value in the function, what do you get? If I substitute 2.9 here, then of course this is very small, and therefore dividing by small gives you a large number, right? Now we have to check whether it is negative or positive. 2.9 will make this as positive, right? So x is 2.9, so 2.9 minus 2 is definitely positive, so we have positive. 2.9 minus that is also positive, so we have positive times positive divided by that is negative, right? So that really means that we are approaching negative infinity. Positive divided by negative means negative infinity, correct? On the other hand, if I write 3.1, both numerators are positive here, right? So we don't have to calculate the value. We are interested in sign. We know that the value is high, and therefore we are writing this as plus infinity, a high value. So what we have found here is that there exists a vertical asymptote, and we have also find or calculated how it approaches vertical asymptote, right? So let me summarize all this in kind of a diagram here, right? So we'll just sketch one diagram here. So let us say that is the diagram, okay? Now in this particular case, we found that our y-intercept is at somewhere here, right? Now, and we do have a vertical asymptote. So let me draw vertical asymptote. Let's say this is 1, this is 2, and this is 3 for us. So I'm drawing a vertical asymptote at x equals to 3. So that is the vertical asymptote. And what we found was that when you are approaching 3 from the left side, the function is going towards negative infinity. But when you are approaching 3 from the right side, the graph of the function goes towards positive infinity, right? So that is the behavior of the graph near the asymptote, especially vertical asymptote in this particular case, which is at 3, correct? We have x-intercepts at 2 and 1, so we can mark those as points. I'll put them lightly with a different color here, right? So these are my x-intercepts, and let us say that we have y-intercept, which is somewhere here, right? So that is my y-intercept. So these are the things which we have calculated so far. Now let's look into other kinds of asymptotes. Since the degree of numerator is 1 higher than that of denominator, what do you expect? We expect oblique asymptote, right? So we have oblique asymptote here. What is the equation of oblique asymptote? We can easily find the equation by dividing numerator by the denominator, right? So let's do that. So let's divide x square minus 3x plus 2 by, so let me make it more interesting, okay, by x minus 3, by x minus 3. So it goes x times, so we get x square minus 3x. When you take it away, it is 0. Bring down 2, that means 2 is the remainder, right? And therefore we can actually write this function as, with the form of oblique asymptote. Using this, we can write this function as f of x equals to x as my oblique asymptote plus the remainder 2 divided by x minus 3, x minus 3. So that is how we can actually write this function. This is another way of writing. So we have written this in factored form and also like this. That clearly indicates that we do have oblique asymptote whose equation is y equals to x. So let me sketch a line here which is y equals to x. So imagine this is a straight line and the equation of this line is y equals to x. Okay, now that's the oblique asymptote. Now we need to consider what happens or how the graph of the function approaches oblique asymptote. That is to say, when x approaches infinity, is the curve above or below the oblique asymptote, right? How can you find that? Now we know equation of oblique asymptote is x, this is x. Above or below means we are trying to analyze this part. If this part is positive, it is above, and if this is negative, it is below, correct? That is what it is. So let us consider when x approaches minus infinity. So when x approaches minus infinity, so we'll not touch this part. We know this is line x, y equals to x. We are only considering that portion, the change or how away the function is from the asymptote, right? It is never touching the asymptote, but it's very, very close. How close and from where? So if I write minus 100, for example, then the denominator is negative and this factor or this term becomes negative. So the value is x minus something, right? So that means we are approaching it from the side below, right? So it is lower. Is it okay? So that is one thing. So we just test this value for, let us say, plus 100. I mean, instead of infinity, we'll take a value 100 and minus 100. So if I substitute plus 100, then this will be x plus something, right? Maybe a small amount. But if I substitute minus 100, then the value will be x minus something, some small amount, right? Now, that means from this side, it is approaching, that is the plus delta, right? That value, right? 100 minus 3 divides into 2, right? So that is very small amount, but it is significant since it is positive above. You get the idea. So from here what we can do is we can get an idea that the graph actually is something like this. So I'm just trying to show you how it should be, right? So this point doesn't seem to be so well, but you know, kind of like this, and then it has to bend from here and go down, correct? And on this side the graph seems to be like kind of like this. This part is very clear to us, correct? Is that okay? And on this side we can say the graph is kind of like this, right? And let's say like this, right? But approaching infinity. Of course this is not to the scale, so you don't really see that part so well. In that case, if this is my x-intercept, this has to be 1 and this has to be 2, right? According to this. And this is minus 2 over 3. So this part is minus 2 over 3, correct? And it is approaching here. However, we are not certain about these turning points, which are our local maximum and local minimum. To find these points, what should we do? We need to analyze the first derivative. So let's find the first derivative for the function. So we'll apply the quotient rule. So in this case, x minus 3 whole square, and the derivative of the numerator is 2x minus 3 times x minus 3, that's the first term, minus second term, which is x square minus 3x plus 2 times the derivative of this, which is 1, right? Now we can simplify this. Let us expand and simplify. 2x times x is 2x square, minus 2 times 3 is 6, x minus 3x plus 9. Let's open this. Minus x square plus 3x minus 2. So we just changed all the signs. Divided by x minus 3 whole square, right? We can now, combine the like terms. 2x square minus x square is x square. Minus 3x plus 3x cancels. We have minus 6x. 9 minus 2 is 7. So we have plus 7 here. Divided by x minus 3 whole square. Now clearly this gives us 3 critical points. 2 because of the numerator being 0, and 1 is of course 3, the vertical asymptote itself, right? Now what is that? This has to be, okay, so we need to apply quadratic formula to find this value, right? Since it cannot be easily factored. Okay, so let us apply the quadratic formula to find the zeros. So that is x square minus 6x plus 7. So x should be equals to minus b, which is 6, plus minus square root of b square. Let me write 6 square minus 4 times 7 times 1 divided by 2 times a, that is 2, right? Let's calculate this value using calculator. Okay. So what we have here is, we'll take first the positive quantity, 6 plus, within square root, we have 6 square minus 4 times 7 equals to, we get some number, we'll divide this by 2. Divide this by 2, and that gives us the answer in decimals. Let's write it down, which seems to be, so one value which we have found is 4.414, right? The other one is 6 minus square root of 6 square minus 4 times 7 equals to, in decimals, divided by 2. And that gives us, in decimals, 1.585. So let's say 1.59. Okay. So we get these two factors for this equation, correct? So let me write this in the factored form so that it becomes easy for us to analyze, right? So what we have here, from these two factors, we can write the function, the derivative of the function f dash x as equal to x minus, let us say 4.4, just for easy calculations, times x minus 1.59, I'm writing 1.6, okay, divided by x minus 3 whole square, right? Now the critical points, as we have seen, are, let's write down, there are 3 critical points. So these are the 3 critical points for us. They are, one is the value 3 itself, right? This is the vertical asymptote. Then we have 1.6. Let us say this is 1.6 and 4.4. So these are approximated to 1 decimal place. Now let us see increasing and decreasing intervals from these. So we'll take test points. Let us say that the test point for this side less than this is, let us say 1, right? And let's take this test point as 2. And here we can take a test point as 4. And let's take this as 5. If I write 1 here, in that case, our derivative will become what? That is negative, right? So this is negative. 1 will make this also negative. Is it okay? And the denominator is always positive. So what we get here is positive, right? So all this is negative times negative. That is to say it is positive, right? Positive means that the graph will be increasing, correct? So in this interval, the graph is going to be increasing. Perfect. Now let us analyze the second interval, which is between these 2 points. If I write 2 here, that is negative, but this will be positive. Denominator is the square, which is positive, so we get negative here, right? Negative means that it will be decreasing, right? So it's just decreasing interval for the function. So this is increasing, decreasing for the function. Is it okay? Now if I write 4 here, then this is negative, this is positive, this is positive, right? So it'd be negative, positive over positive, correct? That is also negative. So it will be again decreasing from this interval, correct? Okay. Now after 4.4, if I write 5 here, in that case positive, positive and positive. When you have 3 positives multiplied or divided, then you get positive, and that positive gives you increasing interval. So clearly from here we do have local maximum at the first critical points. We'll write this as local maximum. We do not have anything here, but we have local minimum at the second that critical point. So this is local minimum. Perfect. So we have a maximum and a minimum value. Minimum is at approximately 4.4 x value, right? And the minimum value is approximately at, I'm writing 1.6, right? Instead of 1.58, 1.6 approximately. Now what you need to do is find the y values for these, correct? You can see so far that the function is increasing in this interval, decreasing thereafter, decreasing. See, you can see it is decreasing. I've shown it so vertical, but it's kind of decreasing. I just squeezed it in, and then increasing thereafter. Perfect. So now we'll find the value of the function at 1.6 and 4.4. So what is f of 1.6? So we're just approximating, right? So we'll do that. Substitute 1.6 in the equation. So you get 1.6 square minus 3 times 1.6 plus 2 equals to, divided by, within bracket, 1.6 minus 3 bracket close equal to. So in decimals it is approximately equals to 0.17, right? So the y value is 0.17. That's the maximum. For minimum, we'll substitute 4.4. So we have 4.4 square. We're substituting in the function itself, minus 3 times 4.4 plus 2 equals to, divided by, within brackets, 4.4 minus 3 bracket close equals to, decimal value is 5.8 approximately, right? So we'll write 5.8 here. So that becomes the local maximum, right? Now that completes our graph. So what we have here is that we have local maxima at approximately 1.6, the value is 0.17. Local minimum value is at 4.4 with maximum value, minimum value of 5.8. And we have vertical asymptote, that's the vertical asymptote at x equals to 3, oblique asymptote as y equals to x. The function approaches oblique asymptote from above as x approaches positive infinity, and it approaches from below as x approaches negative infinity, right? And you can see clearly the vertical asymptote, the function approaches from left side towards negative infinity and from right side towards positive infinity, right? And we have also calculated x and y intercepts. I hope with this you get fairly good idea about how to sketch such functions with kind of accurate values. I hope that helps. Thank you and all the best.